inventions. Top inventions.
The behind-the-scenes tales of hit products and creations from Japan. This is Japan's Top Inventions. On today's show, needles, feared by people of all ages. We explore a needle that was specially designed to make injections less of a pain.
Hello, welcome to Japan's Top Inventions. I'm your host, Jason Danielson. In the first half of the show, we take you behind the creation. Today's topic is this, needles. That prick of a needle can cause a lot of discomfort. And many people have a fear of needles too. This particular needle, released in 2005, was made to reduce the amount of pain during an injection. Development started with something an engineer saw during a visit at the hospital.
A medical equipment manufacturer's R&D building in the greater Tokyo area. The company has been around for a century. Over in this display area, blood packs used at the hospital, and other devices like medical thermometers. Lately, this has been a key product. A low-pain needle. Over 2.1 billion units have shipped in Japan and to regions like Europe and China.
Our company has long been trying to help patients that need injections. We've heard feedback from patients that our needles hurt less to use.
Our story begins back in the year 2000. Men from the company made frequent trips to hospitals. They were salesmen and product developers. These employees would go around to client hospitals, speaking with doctors to get ideas for new products. Nishikawa Hisao was one of those men. He went to the hospitals as a product developer.
As a developer, you had to go directly to the hospitals and speak to the doctors yourself. Otherwise, you wouldn't be able to make a good product. From Hokkaido in the north to Kyushu in the south, we visited hospitals across the nation to get insight.
It was during one of these trips that something caught a developer's attention. A child holding an injector. The child lifted his shirt, steadied himself, and jabbed the needle into his torso. Pain clouded the child's face. The injection was for insulin. The child had type 1 diabetes, meaning his body was unable to produce enough insulin, requiring the hormone to be injected instead. He needed to bear this pain 4 times a day.
Adults have a certain degree of fat under the skin. But children, especially those in early elementary school, have to inject into such a thin body. I wanted to try and ease their pain, if only just by a little.
And so the developers found their goal of making a low-pain needle. They returned to the company to start work right away. How could the pain be lessened? Members of the development team were focusing on the thickness of the needle. The skin is full of pain receptors. The thinner the needle, the lower the odds of it hitting a receptor. A thinner needle would reduce pain. Of course, things weren't so straightforward. A thinner needle meant more resistance as the insulin was pushed out.
When looking at the force required for injection, a thinner needle means less pain, but it requires more force to push the fluid out. We were trying to find a way around this issue. That's what we were working on.
How could they make an extremely thin needle that didn't require a lot of force? The team searched for days for an answer. A member of the team that specialized in fluid mechanics had an idea. We could try tapering the needle. Even with a thin tip, if we make the base thick, the resistance won't go up.
There's a formula for calculating flow in fluid mechanics. Running a simulation based on that formula, if we connected a thicker section to the thin part, the total resistance would go down. It checked out on paper.
However, almost immediately, the team ran into a hurdle. They had never created a needle with this shape. How would they make it? The way to make a conventional needle was to roll up a thin sheet of stainless steel into a tube and weld the gap. Then, the tube would be evenly stretched and cut down to size. Finally, the end would be sharpened to a point. But their needle wasn't even like the older ones. It had a special tapered shape. The conventional method would not work.
With the conventional way, the whole thing has the same diameter. You can't change the thickness partway through. A tapered needle can't be made like this. Honestly, we were worried whether it was possible.
While tapering the needle to reduce pain was a good idea, there was the matter of how it could actually be manufactured. But it wasn't long before the team got help from an unexpected source.
The tapered needle required a new method of manufacturing. The team looked outside the company to find places with the best metalworking capabilities.
We looked for metal workers that could press a variety of shapes. All in all, we had planned to contact about 100 different companies.
The team made an appointment to visit one of the manufacturers. They showed them the tapered shape they wanted. Their response? Sorry, that can't be done. The team continued to look for possible leads, but all the places they visited turned them down. Then, one day, they caught word about a small factory in Old Town Tokyo. They had only 6 employees, but their skill was world famous.
They had become quite famous in the industry by making battery cases for lithium-ion batteries in mobile phones. People called them saviors for metalworking. So, as a last resort, we asked for help.
A team member headed over. He was greeted by this man, Okano Masayuki, head of the company, a master craftsman who had devoted over 50 years to metal press work. The team member explained how everyone said the needle couldn't be made, and how they wanted to help diabetic children. Okano listened to their plea and eagerly accepted. Right away, Okano started prototyping. He prepared a small sheet of metal with angled sides, 0.05 millimeters thick. He pressed the sheet and rolled it into a tapered tube. But there was a problem. The edges needed to meet along the entire shaft. If there were gaps, fluid would leak out. Okano tapped into his years of experience, repeating the process over and over while making fine adjustments. After over a year, he succeeded in making the tapered piece watertight. Okano passed away in 2019. He speaks about that time in this archival interview.
Is there any greater thrill than doing what other people can't? Doing the impossible? It's like mountain climbing. Climbers live to scale impossible heights. It's the same for us at a little factory like this. Is there anything more fun than doing what no one else can?
Okano delivered this thin, tapered tube. The last touch was to finish the tip. It wouldn't be a needle without a pointy end.
A tube doesn't pierce. It would hurt. So we had to make the tip sharp in order to reduce the amount of pain.
Their goal was to create a low-pain needle. Could they do something different about the tip, too? The development team carefully evaluated the possibilities. They landed on the idea of making the tip like a tiny knife for cutting the skin. Here is a close-up of a real needle. A conventional needle tip is symmetrical. And here is the new design. The tip is asymmetric and shaped like a knife. This shape would allow the needle to slide into the skin rather than poking into it, which should cause less pain to the patient.
By making it asymmetrical, the point becomes like a knife instead and cuts into the skin along its curved edge. We thought this would reduce that painful prickling sensation that needles cause.
And so, the world's thinnest needle was finally complete. But did the needle truly hurt less? This required confirmation before the product went on sale. Members of the team headed to hospitals across the country. They asked the doctors to pilot their product. We want to help the patients. Please, can you ask them to try our needle?
We really wanted to help the patients who needed insulin injections. We asked them to try our new needles and rate whether they hurt less than the old ones.
The team members visited hospitals day after day. In the end, a trial comparing the needles was arranged between 6 hospitals. 2 months later, the team members went to Tokyo to attend a medical conference on diabetes. Doctors from the hospitals that tested the new needles were going to announce the results of the study. If their new needle didn't cause any less pain, then all their efforts would have been for nothing. The team awaited the announcement with bated breath.
It was nerve-wracking. We weren't sure if our product really lived up to expectations. We were really nervous to hear what kind of feedback we'd get.
The session began. Their sample needles had been used by 81 diabetic patients. Among this group, How many people thought the new needle caused less pain? What would the result be? This paper contains the results of that announcement. 51 people felt that the new needle caused less pain, over 60% of the group.
I was relieved to see our creation being accepted by others. It was a wonderful thing. It also made me excited to think about how our needles might bring a bit of joy or comfort to patients.
And so, the low-pain needles were finally released. This is from a survey the company did after. It was filled out by a 10-year-old girl with diabetes.
Afterwards, the needles were shipped to places around the world, like in China and Europe, helping people take their medicine with less pain. How do experts view this invention? We're joined by Urakami Tatsuhiko, who treats children with diabetes at a clinic in Tokyo. Welcome to the show.
Thank you.
Does your clinic use these low-pain needles?
Yes, we do. Insulin can't be taken orally. It has to be injected. The low-pain needles are quite a bit thinner than conventional needles, and they look less scary. So when children find they don't hurt as much, or it's nothing to be scared of, they're able to take their injections without much trouble.
I see. What would you say was groundbreaking about these low-pain needles?
I think of these needles like a hair. They really don't hurt compared to needles for drawing blood or vaccines. There's still a tiny prick, but the patient can learn to pick a spot on their body and inject without much pain or worry. When you look at it that way, it's a great tool, I think.
How much of an issue is the pain caused by needles with children?
Type 1 diabetes, when the pancreas isn't able to produce insulin, is commonly found in children. These children have to inject insulin 4 or more times a day. They have to bear that pain thousands of times a year. Low-pain needles reduce that discomfort and improves their quality of life, so it makes a big difference.
Thanks for being here. Good talking with you.
Glad to speak with you.
That's all for this episode of Japan's Top Inventions. We'll leave you with what came next for the needles from the first half of the show. See you next time, and stay inventive.
In terms of diameter, it's 0.02 millimeters thinner and 1 millimeter shorter. We want to do all we can to reduce the pain for patients. We're going to keep chasing after that ideal. Yes, we'll keep working at it.